Take your shoes off at the door. Big data jazz is what we've got in store. Tapping keys like piano notes so sweet. Join the band, find yourself a jazzy seat. Swinging data, sync those beats, charts and graphs and snazzy feats. Clap hands, tap your feet, and GeeCON the data sneak. Big data is here, big data's here. Step right in, big data's here. Flowing, tables glowing, queries swinging fine. Join the rows, the DB knows the answers every time. AI grooving, swiftly moving, answers that can't miss. Step on in, it's data bliss. Swinging data, sync those beats, charts and graphs and snazzy feats. Clap your hands, tap your feet, at GeeCON the data, at GeeCON the data's neat, at GeeCON the data's neat. Let's start the show.
All right. What energies. Good afternoon, GeeCON. It's so happy to be here again. Yes, everything that you've experienced up until this point was AI generated. We will not be talking about how I made that. You can talk to me about this later because we are going to be talking about data. Now, before we start, we're going to have Q&A. Hopefully at the end of this, we'll have some time for that. So if you have any questions, this is where you go. It's the same as for all the conference. Also, we are going to have some audience participation in this one. And I will be giving out some data stars. So try to participate. I will not tell you when you're going to get one and where not. I did not present myself, which is extremely rude. My name is Josef Goldstein. I work in a company called Wix, where I lead the big data and analytics platform, and I'm also an AI geek, and we'll be doing all of that here. Now, I am super excited that all of you came here instead of the other talks to celebrate with me a birthday party. A birthday party to someone so special for all of us. You have no idea what I'm talking about, do you? Of course, I'm talking about the language SQL. I'm talking about the language SQL. Who here is using SQL on their day-to-day? Cool. So I'll have you know that this month, the language SQL is going to celebrate its 51st birthday! Woo! Happy birthday to you! Happy birthday to you! Congratulations, all of you have been using a 5 decades old language. I'm sure you're all going to update your LinkedIn profile now. Now, to be fair, yes, SQL is a fairly ancient language at this point. It's older than C++. Just a little younger than COBOL, but we get to that later. But for a good reason. In the last Stack Overflow survey, SQL came as the #2 most used language by software professionals. So there's probably a good reason for us to talk about it, right? Cool. And before we talk about, jokes on midlife crisis, and we wish some stuff for the future and talk about what's been in the last 51 years, we need to have what every good birthday party has. Anyone knows what that is? Okay, but there's a cake here. There you go. You can't eat it, but we need a magician. Yes, we need a magic show. Every good birthday party needs a magic show, and I think this one is about to start. Let's see. Let's go.
Ladies and gentlemen, for my first trick, I will query data using words.
amazing! What an amazing trick! He just wrote the words into the text box and data appeared, even a SQL query. Amazing trick! Now, I will not be talking about this, I will talk about how we're doing this trick. If you are interested, this is an open source project called RenAI. But to be a bit serious for a second, who here thought that was an impressive magic trick? No one, right? Which is kind of weird, right? Because if I were to show you this 2 or 3 years ago, this would have been impressive. But now, not so much. It's a little bit like when your uncle, that weird uncle, does that magic trick where he tells you which card you thought about for the 100th time. You still have no idea how that happens, but it's just not as impressive as the first time you saw it. And this is kind of interesting, right? So 50 years, 51 years for SQL, but we are at a point in the industry that these two things kind of make sense at the same time. On the one hand side, we are all using a query language that is 51 years old, and we are happily saying that we're using it. On the other hand, we kind of expect the other option to just work. So how is this possible and how are we going to be bridging this? So this is what we're going to be talking about today. But before we do that, we need to do what every significant birthday party needs to have. We're going to be talking about how we got here. So we're going to talk a little bit about the past, about the present, where we are today, and hopefully what the future entails for us. So let's start with the beginning of SQL. That's not how it started. That's not. Anyone recognizes this? Anyone? Can anyone tell me what that is? Space Odyssey, sir. You're getting a data star. I am bad at throwing. I will give the next one after the talk. Yeah, Space Odyssey. Space Odyssey came out at the end of the 60s. So no, this is not how SQL started, even though it would be cool if it did. But how did computers look at the end of the 60s or the early 70s, right? So private computers weren't really a thing at the time. The latest and greatest was IBM's mainframe, System 370. Amazing. And we just started having proper software languages. We just finally had actual monitors where you can type in the language and you don't need to punch holes into a card. This is where we were in the beginning of the 70s. And IBM was a very key player at the time for computers, but especially for data. Because at the 70s, IBM was working on a special project called System R. System R was a project that was meant to give birth to the first relational database in history. Up until that point, the way we wrangled data was using text files and indexed files that you would need to write code that traversed one file to another, to another, to another. And as part of this project, 2 software engineers and researchers by the name of Donald Chamberlain and Raymond Boyce wrote this paper. Did everyone see this before? Right? So that is SQL, a structured English query language. And this is the birth of the language that we now call SQL or SQL, depends on where you're at. And in this paper, they envision a language that will enable easy, simple querying of data to anyone. Now, to kind of understand why this paper was so revolutionary at the time, we need to go back a little bit to understand how does data processing and data querying looked at the beginning of the 70s. Because before SQL, we had COBOL. Did anyone here ever program in COBOL and willing to admit it? No one. So good for you, good for you. So this is a real COBOL program, and yes, it's really hard to read what's happening in there because that's a lot. But basically what this thing does, that is a query. That is a query to perform a report over sales for an account. Now, to kind of get the grasp of how revolutionary SQL was at the time, If we were to write this using modern SQL today, it would look something like this. Mind-blowing, right? Pretty cool, pretty cool. And all of this in order to solve a problem that did not start in the 70s and definitely did not finish yet by the time that we are speaking here right now. And that is, how do we give people, anyone, not only software engineers, the ability to translate their intent, their question, into answers, into data? So at the time, we didn't call it this way, but SQL was our first attempt at self-service for data for laymen. Now, it's kind of interesting to talk about what were the main principles behind the inception of the language. So the first one, and that was obvious, we want a language for casual users. That means we want a language that not only software engineers that know how to code COBOL can use. We want to give anyone the ability to query data. How are we going to do it? We are going to use ordinary language, or at least what we perceived as ordinary language at the time. We're going to be using words like table, like from, like select, right? Familiar with these words. But most importantly, we wanted a language which is declarative and readable. As the paper says, we want a language that has a walk up and read quality to it, right? You can just read it and understand what it does. Or in other words, don't deal with telling me how to get the data that I want, right? But tell me what data do you want. Now, we all know where that got to with SQL, but this is where we started. These are the principles where we started. And that's where we were at 1974. Now, we walk a little bit more down memory lane, down history, and we get to 1979. And in 1979, we are getting the first commercial database, relational database, that supports SQL. Surprisingly enough, the company that releases it is not IBM, the company that invented the language, but a small company called Relational Systems Incorporated. Did anyone here hear about Relational Systems Incorporated? Let me help you. Maybe you know them by their new name, Oracle. So Oracle was the name of the first commercial relational database that supported SQL. And it was such a phenomenal success that the company changed its name to be Oracle. Now, only a few years later, IBM comes up with their database, and they're calling it DB2. Anyone here is familiar with DB2? Okay, that's more than I expected, and no one raised their hands on the COBOL. That's interesting. So for those of you that did not raise your hand, I will tell you that if you own a bank account, and it's not in one of those fancy neo-bank accounts, there's a good chance that your balance is currently being managed on DB2. Now, at the time, we were also getting a lot of very known databases like Sybase, like SQL Server, most of them databases that exist until this day. But something more interesting happened in the 80s. SQL becomes a standard language. It gets ISO standard, ANSI standard. It gets adopted by DARPA. Now, these are things that today mean absolutely nothing to us, but it's the equivalency of having an open source project and have it get 10,000 stars, right? That was the seal of approval that was needed at the time for decision making, and that was the first time where SQL started to become the de facto language of data querying. We run a little bit down memory lane and we get to the 90s. Okay, in the 90s. I think we already have people here that have been writing software during the 90s. Okay, you don't need to be shy about that, that's fine. And the 90s bring us the open source relational databases, right? It brings us MySQL and Postgres and SQLite. And if you guys kind of think, wait, SQLite is kind of weird, why would you mention that? Isn't that esoteric? I'll have you know that SQLite is the database that is deployed the most in the world. Actually, all of you right now are running at least one instance of it in your pocket. It is what your operating system, whether you're using Android or iOS, uses to manage data on your phone. And these databases remain with us until this day. Actually, some would say these are the databases you need to start with when you build a new project. But the reality was a little bit more complicated, because when we went to the 2000s, we got to the internet age. The age of big data. The age of distributed systems. The age of, say it with me now, NoSQL. That's right, NoSQL. And that's the end of the talk, guys. That's where history ended. There was no more SQL after 2000. Right? Right. Wrong! Of course no! Of course! We had a bunch of SQL coming after that. Now, that's kind of an interesting point in time, right? Because at the turn of that century, with the start of big data, analytical data, right, data that you cannot compute on a single node, we kind of went back and we started with MapReduce. Anyone here ever wrote a MapReduce program in their life? Oh, I'm sure you had a lot of fun doing that, did you, right? Because in one way or another, MapReduce was the new COBOL, right? This was the new programming language that is the only way for people to access data. And we kind of lived with that for a few years until a few projects came along, primarily the two ancient fathers, which were Hive, right, part of the Hadoop ecosystem, and Project Dremel in Google. And what they brought was the idea of separating SQL as a language from relational data as a concept. Essentially, let's be able to run SQL on anything. And this is just a short snippet of the evolution of various querying engines, analytical databases, and non-SQL databases that at some point in history realized that they need to support a language like SQL or exactly SQL. And the reason for that are all the simple examples and reasoning we said before behind language, right? We need a language that enables everyone to do something with data, even if they don't know how to write software. And this kind of leads us to where we are today, right? And by the way, I do apologize if there is a certain project that you love and it's not here. This is kind of a zoo. And at the year 2025, SQL, a language that is 51 years old, is actually not going anywhere. So if there's some of you that's very invested, don't feel bad about it. If anything, SQL is becoming a much crazier and more powerful language than it ever was. In order to prove that to you, we need to get to the next part of the birthday party, right? Because every good birthday party has an activity.
Welcome to the game show. What does this query do?
All right, let's start the game. And the game goes like this. I will show you a SQL query. That SQL query is special. There's a good reason for that. The first one that says, what does that query do? Gets a data star. How about that? Let's start with the first one. What does this query do? Bum 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 bum. Anyone? Bum 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 bum. What? Inserting, but sir, inserting to where? To Kafka. How is it inserting into Kafka? Kafka is stream, sir. To Kafka. So I'll give it to you because that's close. So come next after the end of the talk and you'll get a star. So this is not in Kafka Streams. This is in Flink. Anyone here is using Flink? Cool, so this will be cool. So this is a SQL query written in the specific syntax of Flink SQL, which is why, if you'll notice, you have temporal syntax there, right? It says join as of, right? You are able to join streaming real-time data based on time windows. Because what this thing does, it is not a query. It is a streaming pipeline. What it does, it takes a stream of orders in various currencies, right? So that's the first part, right? That's from orders stream. And then it joins it with a stream of the latest exchange rates for all currencies into US dollars, right? So that's the second one, the currency rate. And then it joins them together in order to perform real-time currency conversion over orders. So this is not a query. This is a streaming pipeline. Let's try another one. Let's try another one. This one is tricky. I am warning you. What does this query do? Pum, 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 pum. So we're querying from AWS CM user, right? And we're joining. What? Send message Slack. So you're closer. We're not sending a message, but we are looking for Slack users, right? But are those tables? Are we querying tables here? Anyone has a guess what this does? Permissions, yes. We're looking for users that have administrator permissions in AWS. But are we querying tables here? Or is this doing something else? Email, close. So this was a bit of a trick one because this is based on an engine that only came out last year called SteamPipe. And this is an engine that abstracts API calls into SaaS APIs, like the ones that Slack would expose or AWS would expose. And it provides a SQL abstraction on top of API actions. So essentially what this query does, it performs an API call to your AWS users registry, into the YAM users registry, filters out all the users that are administrators, and then fetches all of their users from Slack so we can bug them or not, I don't know, send them a message or something. So this is not a data query, this is a script that uses APIs. So all those scripts that you're used to doing, CLI stuff, forget about it. Just do it with SQL. Okay, let's take another one. This one's going to be a bit overwhelming. So I'll give you a little bit more time on this. What does this SQL do? Pum 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 pum. Hint: the magic is in green. What does this SQL do? Pum 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 pum. Anyone? Pum pum. Calls ChatGPT. Yes, yes, yes. That's exactly what it does. What gave the hint, right? The name of the model, right? That's interesting. So this is an example using Spark SQL specifically over Databricks. And what it does, it takes all the tables in your schema, then takes all the columns for these tables, package them into a prompt that asks ChatGPT to document the schema of your table and generate that documentation. Now we'll talk a little bit later about why would you want to do that, but this is not a query. This is an AI inference pipeline. And these are just a few examples of where SQL is today. And it's gonna get crazier. And it's going to be more and more similar to programming language as time passes. And this is cool, right? These are some cool examples. I saw some people taking pictures, right? This is cool. But it doesn't bring us any closer to solve the original problem we wanted to solve, which is how do we give people, everyone, the ability to convert their intent, their question, into data, not only professionals. Because as you know, laymen are not that good at writing SQL, as much as we would want them to. And we kind of accepted that, right? We kind of thought, like, that's how it's ever going to be. And that's completely fine. We trained a few more people. We called them data scientists or data analysts, right? And we said, that will be good enough. But then, something changed. Something changed, and like with every major change and every technology that brings a paradigm shift with it, we are kind of reevaluating now what is and isn't possible. We are reevaluating what we took for granted until now. Because the advent of large language models has taught us that these two can be the same. And when you think about it, natural language, which is the thing that large language models are good at, or NLQ, right, natural language query, or the way I like to call it, words. Words are also kind of good at all the things we wanted to achieve with SQL. So we can agree that words are pretty okay for casual users. I mean, if you know English, you can use it, and I'll give you a hint. Large language models are also good with things that are not English. It's an ordering language. I don't think that requires anything else, right? And there's really nothing more declarative and readable than a human language question, right? And we're kind of realizing now that maybe the way we've defined this for SQL was wrong, because when we said, don't tell me how to get the data, but which data you want, and we kind of got that very complicated, what we should have said is, tell me what is your intent and not the specifics on how to get this data and from where. So, guys, everything's over. We are not going to use SQL anymore because we have AI and everything is completely solved. We can stop completely using SQL. The world is a better place to not that fast. So, I think some of you at least have tried the cool trick of opening ChatGPT or Claude or Gemini or whatever your favorite friend, and putting some information about how your table looks, and then asking a question, and then seeing the miraculous birth of a SQL query at the end, and feeling really good about yourself, right? But the reality is kind of more complex, because when you take this into the scale, right, into the real world, things get slightly more complicated. Now, to kind of understand why and what we can do about it, we need to talk a little bit about what are we doing when we're writing and executing a SQL query. Yeah, we have an intent. That's cute, right? So the first thing we need to do is understand what the hell do we even want, right? And in this case, we wish the model to understand what the hell are we even talking about. Now, to be fair, there's a lot of missing context occasionally, but LLMs are fairly good at understanding our intent, right? Now, let's say that we kind of understood what is our intent. What is the question that we want to have an answer to? So the next part is we need to find all the relevant data assets, for example, tables, that we will require in order to answer on this question, right? Now, this is simple if you have 5 tables, right? Fairly simple. Modern systems, whether it's operational ones or analytical ones, tend to have hundreds of tables, thousands of tables, tens of thousands of tables, right? So how do I find the right tables that I need? Now let's say for a second that I found the tables that I need in order to answer this question. How do I get it all together, right? How do I join the tables? How do I perform the logical action that's needed to actually articulate an answer for the question that I had? Now let's imagine that we've already done that. Now we need to take this logical plan that we have in our head on how we're taking those tables and how we're joining them and how we're aggregating and how we're calculating everything. And now we actually need to write a query, right? Now, obviously, the simple thing is, the SQL queries where you have select star from fun, right? The reality is that those of you that have been working with SQL, there are some horrible SQLs out there in the wild. And LLMs, still not doing that well with that, at least not the same way they're doing with more regular, quote-unquote, code, like Python, JavaScript, Java, etc. And let's say that I've created this query, I need to execute it and then look at the result and come up with an answer, right? Because I wasn't looking for a table. I wasn't looking for an answer for my question. Now, yes, we are going to sprinkle some AI on all of these problems in order to solve them. But in order to get us through this flight of stairs, we probably need more than just an LLM. And this is the part of the talk where we are marching into the future. And it is kind of important for me to say that this reality changes extremely fast. I have made changes in this presentation literally weeks ago because things are changing in the way these technologies are working. So it's an important disclaimer to say what I'm going to tell you now is true for what we know right now. And for the guys watching this on YouTube, if this is nonsense, I'm sorry, that's what I knew at this point. But right now, our best guess on how we're going to help that poor LLM get us to self-serve data, right, the thing that we want, is leaning on 3 pillars. And we're going to be talking a little bit about these pillars. And the first one is retrieval augmented generation. Who here is already familiar with the term of RAG? Okay. There's actually a talk about RAG happening right now in another room, so sorry if you're missing it out. So I'll give you the $2 tour, right? So the way to think about retrieval augmented generation is this, right? At the end of the day, large language models have been trained on huge amounts of information, but this is information that exists in the wild. It definitely, or hopefully, was not trained on the specific information that is specific and internal to your company. So that's problem number 1, right? If I ask a question and it just doesn't have that information for it, it doesn't have where to get it. And then you'll say, okay, fine, so just give it the information, right? That we know how to do that. But then comes another problem, and that is there's a certain limitation to the context window that you can give an LLM. Now, I'll touch on that in a second, but as we're seeing, there is only so much information you can give in one prompt, and the more information you put in a prompt, the more trickier it gets for the LLM to find the relevant things inside that prompt. Now, we talked before about having hundreds of tables, thousands of tables, tens of thousands of tables. At some point, you are going to be reaching the cap of that context side. Now, it's kind of important for me to say that what I said right now is a little bit controversial because at least someone saw at some point in the last 6 months an article that says, RAG is dead, RAG is not dead, RAG is a zombie, I don't know. And the reason for that is because we are now getting pretty cool new models that actually have huge context size. Specifically, the latest coming out of Google, Gemini, really, really amazing. And actually, they're also slowly solving problems that have to do with finding the needle in the haystack problem, right? Having a lot of context and being able to pinpoint the good stuff. So we are getting much, much better at that. But the reality is, even if that works, it can slowly become very, very not economic because, as you guys know, you usually pay for these things by the amount of tokens that you send. So is RAG going to be dead or not? Probably not. Depending on the use case, maybe. But I still didn't explain what RAG is, right? So for those of you that are uninitiated, imagine this. Let's say that I want to answer a question based on some information that exists in a library. I'm not going to go into that library and I'm going to read all the books, right? That's not feasible, right? The same as we're not going to give all the information in the world every single time to our model. What I'm going to do is I'm going to go talk to the librarian, and he or she will recommend the books that probably are going to have the information. I'm going to go and take those books, and if I'm smart enough, I might even look at the index for each one of those books to try to find the relevant chapter. And then I'm going to read these chapters and hopefully find the answer there. The idea of retrieval augmented generation is the same as that. We want to do that for the model. We want to retrieve the relevant information that we believe will be helpful for answering this question and provide it to the model together with the original question that came from the user. Simple, right? And obviously now it became extremely fashionable to do this search using things like semantic search, right? Using semantic vectors. We'll not go into that, even though that is kind of the state of the art right now. And then you need to ask yourself, okay, fine. Let's say I'm bought in, RAG, cool, makes sense, a lot of data. What am I going to put in that library? What am I going to put in that semantic index? Right? So the obvious question is, the answer is, I'm just going to put there the schema of all my tables, right? So if I have 100 tables, it's going to be a schema of 100, etc. But then you come to other problems, and that is how everything comes together, right? So just knowing which tables I have is probably not good enough to know how I need to join them into answering a question. There's another problem, which is there's a lot of ambiguity on the definition of measures. So for example, I might define an active user in one way, and another company defined it in another way. And if I'm not going to explain my dear model what an active user is, the model is just going to guess, right? And the same is true for things that are even more sensitive, like revenue, for example. So how are we solving that problem? And here comes something that might be less familiar for some of you. Who here heard about semantic layers? Cool, cool. I saw at least 2 hands. That's great. So for the uninitiated, semantic layers, and there's no like one type of semantic layer. There's no one standard for semantic layers. You can think about it as an abstraction layer on top of your data. An abstraction layer that acts sort of like a knowledge graph that tells the story about the relationship of all the tables or all the data assets that exists in your world, together with the semantic qualities of what does joining them mean. And then once you have this, you're building additional relationships and additional nodes in the graph that explains business concepts that exist in your organization. What is an active user? What is revenue? How do I infer those from the tables, and how do they join to answer that? So you can really think about it like a graph. Now, there's a lot of implementations to that. Most of them usually come with an engine that actually generates SQL. So imagine that if I have a graph that describes all the relationship between all my data assets, I can create a very simplified language to query and then have an engine that have the mapping between all my data assets generate a very, very potentially complicated SQL that will answer that question. And that kind of solves another interesting problem, which is LLMs are still not very good at writing complicated SQLs. So we're taking the part that we don't want to be non-deterministic and we're turning it into deterministic. And then what we put in our RAG layer is the simplified version of all the business terms and assets as they are defined in the semantic layer. But that is not good enough, right? Because the terminologies can also get a little bit confusing, and they're different from company to company. So when I say active user, is it the same as when I'm saying active account, right? When I'm mentioning a name of a product, how is the LLM supposed to know that revenue for this product is different from revenue to that product, and there it's calculated this and that? Like, there's a lot of information about what is the right way to think through the semantic layer, through the semantics of our business. And that leads us to the third pillar. Metadata, documentation, business glossaries, business ontologies. Essentially, all the knowledge, the lore that exists inside the heads of product managers, data analysts, data scientists, data engineers, software engineers, business people, taken out of their skull and written into a place that is accessible to the LLM side by side together with the semantic layer. And there's other metadata that might be interesting, like who uses which data and when. When a person from marketing asks a question, he might have a different expectation than someone from sales. And that metadata is very powerful to power a good question answering model. Now, if you follow on what I said right now, you can understand that there's a new thing that now will be required to make all of this work, right? And those are new responsibilities for people around us. So this might not be you, but those might be the people that have data in their title that's sitting next to you in the office. Because those people that were used until now to be the data storytellers, let me run a query for you and tell you what that query retrieves, now need to teach the system, teach the model how to tell these stories. How? By generating all this metadata, by generating all this documentation. Now, in reality, it's even more complicated than what I tried to simplify here, and there's only so much depth that I can go into in a talk like this. But if you are kind of interested in that, this is an article that we've published at Wix last week, and it goes into depth of how are we building this AI assistant that answers questions using agentic workflows, how did we do RAG, how we're building RAG over synthetic data, which I think is a very cool concept that we can't go into right now. So, pretty good reading if you want to hear more about this. But we have a little bit of time, so I want to talk about something completely different. The name of this talk is The Future of Data is Words. Now that has more than one meaning in my head. And it has to do with not the data directly, but the systems that we build right now. So we all got used to systems that look like this, right? Form systems, web systems, right? Systems of record that have some kind of a form or click-through behavior. But the reality is that this world is changing. So if the data that these systems generated was extremely structured, right? We can explain it in a JSON, or we can explain it in a columnar format. We are approaching a new user experience reality. And we're all seeing it today, right? We are spending much more time conversing with our dear old friend ChatGPT or Claude than clicking through things. And we're going to be seeing more and more of these systems that don't rely on you using your mouse, clicking through things, or filling forms with your keyboard, but having these very, very hopefully productive conversations with the agent of LLM. And the output of these systems is highly unstructured. It's literally a conversation, or in the very near future, vocal conversation, right? Because voice-based agents is a thing. And now, true that behind all of these agents, there are still going to be, at least for the near future, systems of record. So all those servers, microservices, exposing an API, managing this data in some kind of a relational database or some kind of a NoSQL database. But everything leading up until that point, the user experience, the conversations our agents are having with one another in order to solve a problem, all of this is going to be highly unstructured. And then you need to ask yourself the question of how are we going to query that data? And that leads me to this toy example from before, right? Where we used SQL to perform inference over an LLM. Now, this is a toy example, right, that documents your data, because now you need to document your data so your question answering can help it. But how about this example, which is slightly more grounded in reality? So let's imagine that now my product has this AI assistant, AI agent that performs customer care, customer support. And I want to ask the simple question, is it good? Are people happy? What is the sentiment? What is the sentiment of these conversations, right? Now, it's not like we never had chatbot until now, but it's becoming a commodity, and we'll need to solve this. We'll need to be able to answer what is the sentiment of this conversation. And we're probably going to have more and more queries that look like this, right? So in this case, I'm calling sentiment analysis, but it's very obvious for all of you that sentiment analysis, that function that's UDF, is going to call an LLM or a small language model in order to perform inference. But if we're talking about RAG, we might even have to index our data in a way that is RAG friendly. So if what we're expecting to do is do semantic search in order to do RAG, then our data needs to be quote unquote RAG ready. And then we'll do something like this, right? We're creating a vector, right? We're actually creating a definition of calling a model, right, that generates embedding. Embedding is how we're converting text into a semantic vector that later can be in a vector space that we can run vector searches on. And then we're actually adding it as, quote unquote, an index to index all the data that exists in our other table, right? So we can query a question on all the messages in our blog, for example. Now, this might look like science fiction. This is Postgres. This is real. You can run this today using PG Vector. So PG Vector is a plugin for Postgres that enables you to basically build a semantic vector index side by side with your data. But if you followed on everything that I said, you might ask yourself an interesting question by this point, because if AI is going to be writing the queries for us, but the queries themselves are going to analyze highly unstructured data, so they in themselves will need to perform inference using AI models. So we're going to have AI querying with AI. Why do we even need SQL? Now, that's a question that I really don't know the answer to. And maybe by the time someone watches this online, there'll be a clearer answer. But we are going towards a very interesting future. So before we finish, let me give my bets. And For those of you watching this on YouTube a year later, you can tell me if I was right or not. So my first bet is, we kind of got used to the cliche of data is the new gold. Data is the new whatever, right? And that's true, by the way. Right? Data is going to become significantly more important as AI gets stronger into our lives. But metadata, right? The information that we have about our information is going to become critically more important. The companies that will be able to collect all this semantic information and put it down into the system will be the ones rewarded with high-quality self-service data. Second bet, we're going to be seeing more and more semantic layers. Now, that doesn't necessarily mean that you will personally have to deploy a semantic layer. It doesn't even mean that there's going to be semantic layers deployed standalone. What it means is that our databases probably are going to start becoming more inclusive of the semantic layer capabilities. And we're already seeing these today in places like Databricks and like Snowflake. The third bet, and that just comes from the semantic layer. Semantic layers usually end up exposing two types of interfaces. They expose SQL interfaces to us poor humans that like to write SQL. But they also expose applicative interfaces in the form of APIs for machines to integrate with them. Guess which one of those an AI agent would prefer to integrate with? And we might end up seeing dedicated ways for querying data for AI agents that maybe even skip SQL completely. And that leads to the last and biggest bet of all. Are there going to be new databases that do not exist today that are purposefully built for AI systems? Databases that are integrated with model inferences, that are built for holding non-structured data and are optimized for AI agents to query them on the other end. Now, I'm looking at all of you. I can barely see you. There's a lot of light in my face. But I see the ones here that are like, what the hell are you talking about? This is, come on, I'm still going to be writing SQL. And some of you are like, yeah, I want it. I want it. It should be here already. And you're probably, both are right. So it'll probably take much longer than we think to get to all of this progress, but trust on me when I say this. This will happen much faster than you think. Thank you, guys. I hope this was interesting to you. There's only so much we can cover in 1 hour. If this excites you, reach out. Hit me up on LinkedIn. Hit me up on email. We can talk a bit more about this. Thank you all. And let's see if we have any questions now from the crowd. Are we seeing this? Good. Am I sharing the right screen? Maybe this is not. Yeah? Cool. No questions. Cool. So if anyone has any questions, I'll be here after that. Thank you, guys.